Hello, welcome back to the channel. So let's cover a new concept in this video and in the upcoming videos as well, which is about integration by parts. So in the previous videos, we covered the concept of volume calculation using definite integrals. In this video, we'll start a new concept, which is integration by parts, and we'll discuss when we have to use this concept in order to solve our definite or indefinite integrals in this case. Don't worry about the formula. We'll go over the formula in detail as well. But the basic idea of integration by parts is whenever you have a combination of two functions in your definite or indefinite integral and there is no other way to solve the indefinite integral or the definite integral, there is no other way using substitution or using all the general methods of integration in order to solve the integral for a combination of two functions. That is the point where we use integration by parts. So integration by parts is used when you have a combination of two functions and it's not easier to solve the integral of the combination of both functions by using the normal methods that we discussed in the previous videos. So if that is the case, we use integration by parts in order to solve these type of questions. For example, in this question, we have to evaluate the integral of x log x, right? So now we realize in this case that we have a combination of two functions. One function is x, the other function is log x, right? And in this case, there is no other way to solve this indefinite integral, right? We cannot solve it using the general method of integration, and also we cannot solve this by using substitution by any means in this case, right? So that is why it will give us an indication that we have to use integration by parts in order to solve this question, because we have a combination of two functions and there is no other method to solve the integral for the combination of both of these functions. And the general idea about integration by parts is, if you have two functions over here, if you have a combination of two functions over here and you're calculating the indefinite integral or the definite integral in this case, you take the first function as it is, integrate the second function and have it in your first expression, and then for the second expression, you differentiate your first function, integrate your second function, and then integrate this whole expression over here. So for the second expression, you're differentiating your first function, integrating your second function, and then integrating the result of what you got in the second expression over here, right? And then when you have both of these expressions over here, you'll subtract both of these expressions, and if this is an indefinite integral, you'll add the constant of integration. If this is a definite integral, you will use the limits in order to solve this integration by parts question. Don't worry about the formula. Don't worry if you still didn't get the approach on how to solve the integration by parts question. We will do this example and we'll have a good idea about what we have to do in order to solve this indefinite integral using integration by parts. But the only thing that you have to keep in mind in these type of questions is, whenever you are using integration by parts, while you are considering your first and second function, always consider your second function to be the one you already know an integral for. Because for the second function, we are calculating the integral of the second function in most cases. So that is why while choosing your first and second function, for your second function, choose a function in the expression for which you already know an integral for. I hope that makes sense. Feel free to comment down if you still have any doubts related to this part. So now let's move on to solve the integral in this case. So our original integral is x log x, right? So first of all, you have to identify the two functions given in this expression, which are clearly x and log x. And now we have to choose our functions based on the first choice of a function and the second choice of a function. And you remember I said in the beginning that whenever you have to choose your first and the second function, always choose the second function to be the one you already know an integral for. So in this case, we don't know about the integral of log x, but we definitely know the integral for x in this case, right? So that is why this is x log dx. So that is why while choosing our first and second function, let's assume the first function to be log x and the second function, because we already know an integral for x, let's choose the second function to be x in this case, right? And now in order to solve this expression, what we have to do is, so this integral expression would be first function as it is. The first function is log x. First function as it is, integration of second, so I'll represent integration of second, right? First function as it is, integration of second minus differentiation of first, which is the differentiation of log x, right? Differentiation of first, integration of second again, so integration of second is this one, and then whatever expression we have for the second expression, we'll take an integral for the second expression in this case, right? So we again use the same formula, which is first function as it is, integration of second minus differentiation of first, integration of second, and then integration of the whole second expression at last, right? So now let's calculate this, and then at last we'll adjust the constant of integration as well, right? So if we solve this, this would be log x times integration of x is x square by 2, right? So it would be x square by 2 because integration of x dx is x square by 2, right? And again we'll adjust the constant of integration at the end, right? So we are done with the first expression. Now let's calculate the second expression. So the second expression would be minus d by dx of log x is 1 by x. So it is 1 by x in this case times integral of x dx is x square by 2 again. So this is x square by 2, and then whatever expression we have over here, we take the integral of that whole expression over here, right? So we'll take the integral of the whole expression with a dx in this case. So again, further simplifying it down, we are done with our first term, which is x square by 2 log of x minus, for this expression x can be cancelled out, right? So you'll be left with integral x by 2 dx over here, right? And then your final answer would be x square by 2 log of x minus integral of x by 2 would be 1 by 2 times the integral of x dx, right? So it would be 1 by 2 times the integral of x dx. Again, it would be, the final answer would be x square by 2 log x minus 1 by 2 times the integral of x dx is x square by 2 again. So it would be x square by 4, right? Because 1 by 2 times x square by 2 is x square by 4. And then once you're done with all these steps, you'll add the constant of integration at the last because it's an indefinite integral, right? So that's the main idea about integration by parts. The basic approach is whenever you have a combination of two functions and there is no other way, there is no other general way in order to solve this type of indefinite or definite integral, you usually go with integration by parts. And if you want to integrate by parts, you use this formula, which is basically first function as it is, integration of second minus differentiation of first, integration of second, and the whole integration of the second expression. And then if you're calculating an indefinite integral, you'll add a constant of integration in this case. And that is what we did in order to solve this expression of integral x log x dx. So that's it for this video. Feel free to comment down if you still have any doubts or questions related to any part. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.